everybody. How are you guys doing? Woo! Yeah, although I have to make a small correction. I'm CTO and founder. I'll tell you about myself in a second. CEO is Chris. Chris is probably somewhere here. Hello, Chris. I can see you, but yeah, anyway. Let's get started. So, Mike, CTO and founder at Callstack. Been working with and on React Native for a couple of years, since 2016. Kind of helped a bit with releases, working on a few projects, and then lately had been shipping some community packages as well. And as Sean said, we're proud to be co-organizing this conference, second time in a row, and I'm very pleased to see all of you, some friends, some new faces. It is so exciting to be back in Vegas again. So at Callstack, we are a software consultancy building universal apps with React and React Native for almost 10 years now. There is a bunch of us wearing purple t-shirts right outside on the left side. If you have any questions about React Native, want to get started with it, or just build something cool with React, let's chat after my talk or somewhere throughout the day. Let's go. Quick show of hands. Who here is a React developer? That's an easy one. All right. So the ones who didn't raise your hands, you're either not listening or you're in the wrong place. Either way, welcome. Now, raise your hand if you're building just for the web. Okay, we have a mixed audience here, although given the previous question, I'm not sure how to interpret that one, but let's just pretend that it's most of us. Now, we live in this world where React is one of the most dominant UI frameworks on the planet. Yet, as React developers, we often think that our impact stops at the edge of the browser. And today, I want to talk to you a bit about how can we change that. Let's think about mobile apps. They aren't static. They have some sort of dynamic content that needs to be delivered without shipping a new version to the App Store. The content is often complex, driven by JSON structures from the server, and it needs to be updated constantly or even changed real time. How do we render these complex, server-driven UIs without constant App Store updates? You might not realize this, especially if you're working on the web, but the answer is very often React. It's the apps that you're working on and building running inside a little box called a web view. And by the way, all these free applications you see on the right-hand side, these are all web views. Not only third-class citizens in the mobile app, actually, I would say, key or core user flows implemented in a web view. So what is a web view? It's essentially an embedded web browser directly within your native application, primarily for rendering your web code, such as some components rendered with React. And on desktop, the browser engine is entirely up to the user preference. Popular choices include, Google Chrome, Safari, Firefox. However, on mobile, the landscape is slightly different. On iOS, all web views are powered by WebKit, which uses JSC under the hood, and developers cannot really change that. On Android, web views are slightly more customizable, but generally they're Chromium with a V8 under the hood. While this approach might seem convenient at a first glance, right? You can just drop in your React code and get it running on mobile. It comes with some significant trade-offs. I'm sure you're mostly aware of them. The first trade-off is the user experience, and you can feel when you're in a web view unless it's a very well-made integration, and I really tried to find something ultra bad. Usually the gestures don't feel quite responsive. It lacks this smooth feeling. You can see the the pop-up on the bottom is not really a native one, and this is primary user flow booking tickets, right? This can be done right if you spend enough time optimizing that, and companies like Shopify demonstrated how far you can push web views. Although for most of us, I guess we can spend that time elsewhere. Then there are technical trade-offs. Getting WebView to trigger a native sheet, talk with your native application, access the camera requires building complex, fragile communication bridges that are difficult to maintain. And if you've been following React Native older architecture or the bridge, you know how challenging it can be to get right. And as a part of that, every message has to often be serialized, which means if you want to cross this boundary with some complex data structures, you will be facing some significant bottlenecks when it comes to performance and serialization. That's why you can often detect a web view when you're dealing with it. Finally, this setup introduces a subtle friction when it comes to the development process itself. To achieve good user experience, the web team has to constantly be in sync with the native team to sort of be aware of how the code is actually utilized. This creates a fuzzy boundary of ownership across both teams, as they have to coordinate all the time, and generally slows the velocity when you want to ship features really fast. So this is the kind of situation, right? Our React skills are creating first-class experience on the web, yet the same code delivers not so good experience on mobile just because of the way it is running. And it is important to realize that the problem here isn't necessarily React, it's more the way we are putting that on mobile. So the web view, you can think of it as a sort of barrier, isolating our components from the native platform and creating all those performance and integrations issues we've discussed. So what if we could just remove the box? What if we could take the React components we write, our logic, our state management and components, and have them render real native UI on mobile? Well, turns out the answer is React Native, and this is how and what React Native was designed to do. It is the technology that lets you run React components on mobile with native performance and native features. And to understand how this works, it is helpful to remember the place of React in this whole landscape. It is a library for managing your UI in the memory, and it needs a renderer to actually display anything on screen. And for years, we've been using React DOM, which provides platform-specific host components, in this case, HTML elements like div. And React Native is just a different renderer that comes with its own set of host components that we will explore later. So how do we begin this upgrade? Well, the story of adapting React Native is similar to the story of adapting React. It starts with the idea that you don't have to change everything at once. You can start small. And React was first introduced in the web world, to manage just a small part of the page. And I guess, based on the talks that we've heard today, we don't necessarily talk about Brownfield React anymore, but I remember, one of the first React conferences back in 2015, like half of the conference was about how you can render React just to manage small piece of the tree, maybe together with Angular or Backbone. That far, we've come, and it's really tremendous. But that kind of architecture is often called Brownfield, which means nothing more than just introducing other technology into an existing established application. And React Native was designed to do exactly the same, but for mobile. You can fit it right into your existing mobile application and live alongside it, letting you immediately shortcut across all the platforms, not just iOS, Android, but also other platforms like maybe Vega. And how is that possible? Well, at a very low level, React Native is just another kind of a native view. You can render it instead of regular view anywhere in your tree, enabling instant code sharing across iOS and Android. And let me show you what it actually looks like. So this is Swift code that renders web view and loads your React application into it. And I'm using web view as an example here because we're sort of taking this assumption that there is React code running inside. But you can use any kind of other view you wish to replace to shortcode immediately. Say, maybe you have native screens on iOS and Android looking the same. You will have something else here, but the idea will be the same throughout the talk. This is what loading React Native view looks like. We're still just embedding a view, but this one is powered by React Native. We first start React Native instance whatever we feel is optimal, typically in this case during the life cycle of the view. And then we create a React Native view that will point to one of the modules that our React Native application exposes. Now, the changes are minimal, but the impact on performance and capabilities is really big. And you're probably wondering where those APIs like React Native Brownfield or React Native View come from. And they're not part of React Native itself, so let me break that process down a bit. It all starts with a simple React Native application. And inside that application, we typically call app registry, register component at the bottom. This is where we tell React Native, hey, these are my components that I'm looking to render from at the native side. Typically, every React Native application will have just one. Then the next question is, how do we get that React Native application into our native application? Well, this is where Brownfield can get tricky, but we really wanted to make it simple. And for years, we've been helping large companies adapt React Native, and for them, this is the only way to get started. And based on our learnings, we've created a library called React Native Brownfield. The helpers we saw, like React Native View, come from this package. They let you add React Native as a whole screen. This is one on the left, the view controller, or just part of the screen, which is on the right, React Native view. Our library will handle runtime initialization, rendering of components, bridging navigation, pretty much most of the hard work for you, and you get to pick where you really want to render your new cross-platform UI. So React Native Brownfield provides runtime helpers, but we still need to deliver the code. And this is where our packaging approach comes in. And we've built a tool called Rock to help you with that. So you take your entire React Native application, and we bundle it into a single native library called XC Framework on iOS or AAR on Android. What's inside? Well, these artifacts contain everything that is needed for your application to run. That would be React Native runtime, native modules, JS bundle, assets. Everything is included in this one self-contained single file. Now, depending on how your native development pipeline is structured, you may have different way to send this to your native teams, but it can be as simple as just dropping that inside your existing mobile application, and then you can immediately refer React Native from your native app without impacting your development pipeline. So we've established how to get React Native view on the screen. The next question is, what do we put inside? And let's take a look at typical screen. This is something that I got when I asked ChatGPT to sort of help me with a typical screen. So let's pretend it's a typical screen. And in order to understand what it takes to run this on React Native, we have to zoom in. Because in React, a screen is never a monolith. It is always composed out of smaller building blocks. So to understand what it takes to run a bigger React screen with React Native on mobile, we have to understand what it really takes to run a smaller component like this on the screen. So let's have a look. First is the logic. It's the easy part. The React Native environment is designed to be mostly web compatible. So you can expect things like use state and use effect to kind of work out of the box. You can also use fetch and other libraries from the web ecosystem for the most part. The bottom line here is that your business logic is largely portable. The challenge is the view layer. And on the web, we render to the DOM using primitives like div. But on mobile, there is no DOM. I mean, we're getting more and more of it now. But iOS and Android primarily have their own primitives for building native UIs. So to bridge this gap, React Native provides its own set of host components like Vue that will act as a universal abstraction over these platform-specific native elements. Which brings us to the core difference. Web has div, React Native has a view, right? And they're conceptually similar. They're both containers for some elements, but they're not the same. So does this mean we have to maintain two separate UI components or even UI trees to make universal UI and make universal code? Generally, no. I mean, my favorite answer, it depends how far you want to go. But at the lowest level, the UI is always different and platform specific. So let's have a look at the most fundamental primitive, how this is done in React Native first. The easiest and most fundamental way to do this is using platform extensions. React Native bundler called Metro has this feature where if you use .native TSX, that file will be loaded when it's running on the native side. And then if you use Metro on the web or maybe use Webpack and pre-configure aliases, you can have the .web run on the web. Which means that on mobile, you can use text from React Native, and then you can take advantage of mobile optimized experience, while on the web, you can run something that is relevant for the web, in this case, paragraph with container. And then when we import given component from anywhere in our application, bundler will automatically pick the right file. That way, our parent stays platform agnostic, and from that point onwards, we can all go with a single implementation. It's kind of a very powerful, simple but powerful primitive, although you don't have to build it all from scratch every time. That would be a wasted time. And community has been creating amazing libraries, and the one you've heard today about is the React Strict DOM, which brings a familiar HTML syntax to a universal platform agnostic model. And what you see here looks like ordinary HTML. But it's actually a set of typed cross-platform React components that can render consistently across the platforms. So what does, say, HTML become? Well, on the web, as we can expect, it's an H1 component. And then on mobile, React strict DOM will map it to whatever is relevant for React Native, and in this case, it's using text component under the hood. But it's not just that, it's actually more than that. One of the things it does is it actually unifies styling across platforms. So in this case, the styling defaults to 1.5 REM, and that way you can get best of both worlds, consistent base UI across all the platforms, and then you can go from there and style it. Another great library that I wanted to call out is Native Wind. It lets you style your mobile components using Tailwind classes, depending on whether you're a fan of that or not. But in case you're a fan, it's great that you can share your design systems and use familiar syntax to build UI interfaces on React Native. And all of these tools build on the same foundation, giving you a ready-made toolkit for writing code that works across all the platforms. But what if your logic needs to interact with platform APIs, like getting OS name? Well, you can also create two files as you expect. You can build on that same primitive. For example, let's say we want to have the name of the OS. In React Native, we can use platform module. And great thing about React Native when you're starting your development career from React Native is that a lot of things come included out of the box. So your environment, your APIs, like platform, everything is there. And all it takes is just get the OS property from platform. On the web, you can get that information out of user agents. So to make it easier, it is often useful to use a third-party parser, like in this case. When done, you can simply import the module from the parent. And again, the bundler will resolve the right implementation. But just like with UI, you don't have to write this all yourself. That would, again, be wasted time. This is where universal libraries come in. And in this case, a great example is Expo Device. That gives you universal implementation of device module across Android, iOS, and web. And that goes way beyond just device. The Expo SDK contains a bunch of different modules, camera, contact, file system, all from a single consistent API. This is what truly allows you to write your business logic once and have it run across all the platforms. So because we now have this universal component model, the trade-offs we saw with WebView simply dissolve. First of all, the performance challenge is solved. Our performance is smoother. The integration with native pieces is better. The post-message bridge and the whole communication is greatly simplified because with React Native, we can have synchronous and asynchronous direct access with shared memory, which means that complex data structures are very easy to work with. And these are the things that make React Native new architecture so much powerful and faster. And the ownership is greatly resolved as well because there is now a single team working not just across Android and iOS, but very often also across the web. So we get to ship from a single code base to many platforms. So solving those trade-offs is a huge win, but it's just the beginning. This is where we move from fixing problems to unlocking potential. Let's have a look at a very simple application hierarchy now. Again, this is actually got this from Google. It's hierarchy of a random application. We have 3 main user flows: scheduling, drawing, profile. I guess familiar to an extent to everything that we are all working on as well. Like I said, the journey becomes with a very first step of swapping a single view. Now, the case I'm making in this talk is to start with a web view, because typically you might be having React code that is easier to move to React Native rather than starting from both native implementations. But alternatively, if you're not using web views or you're having other similar UIs that look across iOS and Android and web very much the same, you can start with something like that here. You prove the concept, you open the door for gradual migration, you set yourself some KPIs, and then you know you can go further. Once that piece is in place, you can gradually expand further and further, moving more screens to React Native, eventually letting it manage entire user flows. This allows you to migrate at your own pace, eventually replacing as much of the old application as it makes sense. And again, if your application is already using web views, you have good first candidate and most likely team that is already well familiar with the concept of Brownfield. So we've seen what is possible, but this amazing potential doesn't mean anything until we really make it reality in our organizations. And the good news is you don't need a grand plan or a massive budget. All you have to do is start this conversation with your colleagues. Where are you using web views right now? And show them how this integration simple is. Because you all have the skills, knowledge necessary to get this implemented in production and benefit from much better UI and user experience. So to recap, we've seen that web views are often a compromise and very challenging to get right. And React Native solves this problem and also can be added incrementally to existing mobile applications. We can use that to unlock meaningful code sharing across your logic and even UI, making your entire organization more efficient. So I think this all comes down to a shift in perspective. You know, for a long time, we thought of ourselves React Web developers and React Native developers, and I've been going to a lot of conferences, and very often there is a second track for React Native and separate track for React. But I don't think that's a full picture. In my opinion, we're developers who are experts at building very nice user interfaces with React. And React Native to me isn't a different career, it's just a different target for the skills you already have. And if you think React Native is not for you, nothing could be further from the truth, so I encourage you to try it and ship some great user experiences across multi-platforms with single code base. Thank you very much.